This website allows you to plug dots into the scatter plot, and it tells you what type of correlation you have. So if I make the dots closely follow the line like they are here, then that's a strong positive correlation. But if I put in a lot of dots that are far away from the line, like they are here, then it becomes a weak positive correlation. So you could think of it as the correlation becomes weaker, the scatter plot is kind of expanding out, and with more dots that are farther away from the line. So as the correlation is becoming weaker, it's kind of expanding like a balloon. It's kind of like you're blowing up a balloon. If the dots closely follow a line going down from left to right, then it's a strong negative correlation. But if I add in more dots that are further away from the line, it becomes a weaker negative. So now it's become a weak negative because now there's a lot of dots that don't follow the line very closely. And when it becomes a weaker negative, it's harder to even see that it's a negative correlation at all, because it's starting to look more and more like no correlation. So as it becomes weaker, the negative correlation becomes less and less obvious. And if the dots don't rise or fall from left to right, then it's no correlation. If the line is flat like this. And I said that when you're dealing with a positive and a negative correlation, then the strength depends on how far the dots are from the line. Because if the dots are close to the line like this, it's a strong positive. And if you have dots further away from the line like this, it's a weak positive, because these dots are moving out further from the line like they are here. And I said that the same thing is true for a negative correlation. If the dots are close to this line, it's a strong negative. But when you add in these dots further away, it becomes a weak negative. Like this. This becomes a weak negative. Sorry. I'll do that again. So this is, it says it's more of a weak negative. Strong negative. Sorry. I'll add in some dots down here. So now it's becoming more of a weak negative because the dots are moving out further from the line. So the strength of a positive or a negative correlation depends on how far the dots are from the line. But if it's no correlation at all, then it actually doesn't matter how far the dots are from the line, because even if I add some dots down here and up here, it's still no correlation. So if there's no correlation, then it actually doesn't matter how close the dots are to the line. It's still just no correlation. For example, my main point is, even if the dots are really close to the line like they are here, it would still just be no correlation, because the dots aren't rising or falling from left to right. You wouldn't say that it's a strong no correlation, because there's no such thing as a strong no correlation. And next I'll talk about how there's actually a value that can be used to measure the strength of a correlation. There's a value called the correlation coefficient. It can be calculated with the data set. And the correlation coefficient goes from, it can take on a value anywhere between -1 and +1, meaning the value has to be somewhere between -1 and +1. If the value comes out to 0, it means that the data is showing no correlation at all. And if the value comes out to a negative number, it means that the data set is showing a negative correlation. And if the value comes out to a positive number, it means that the data set is showing a positive correlation. And actually, if the value comes out further from 0 and closer to -1, it means that the data set is showing a stronger negative correlation. And the value further from 0 and closer to +1 is showing a stronger positive correlation. And 0 is just no correlation. If it comes out to -1, it means that the data set is showing a perfect negative correlation. And if it comes out to +1, it means that the data is showing a perfect positive correlation. And I'll show you what a perfect negative and a perfect positive would look like. I'll go back to the website. If the dots all perfectly line up on a straight line going from left to right, it's a perfect positive correlation. So this data set would have a correlation, would come out to a value of +1. And if the dots perfectly follow a line that's dropping like this, then it's a perfect negative correlation. So this would be a value, this would come out to a value of -1, which is a perfect negative correlation. And this value that I'm talking about that tells you how strong the correlation is called a correlation coefficient. And they use the letter R to stand for the correlation coefficient. So if you see something that says R equals 0.74, then that would mean that the correlation coefficient is 0.74 because The letter R stands for correlation coefficient. And now I'll go back to the website to actually show you a demonstration of the correlation coefficient. There's another graph down here that can do it. Here we have a data set, and we can set the correlation coefficient, which is the letter R, to a certain number, and it'll show us what that data set would look like. This is a data set with a correlation coefficient of 0. So this is pretty much no correlation because the dots aren't rising or falling from left to right. And as we move up closer to 1, we're seeing a stronger and stronger positive correlation. So this is getting stronger and stronger. It still says weak because down here it still says weak because the dots are still pretty far from the line. Sorry. It looks like the dots are still pretty far from the line, so it's still pretty weak. But as we move up toward 1, it's getting stronger and stronger. And once we get to 1, that's a perfect positive, which is as strong as it can possibly be. Then once we move back down to 0, we're getting weaker and weaker positive correlations. And then 0 is no correlation, which is as weak as it could possibly be. And then as we move down toward -1, we're getting to see stronger and stronger negative correlations. And once you get to -1, it's a perfect negative correlation, which is as strong as it can possibly be. You can't have a negative correlation that's any stronger than this. Next, I'll show you some examples of calculating a correlation coefficient with Excel.